As promised, here is lesson 4.4, quadratic formula and the discriminants. These are the answers to this worksheet. Solve each quadratic equation using the quadratic formula. Find the value of each discriminant, then determine the nature of the roots. And of course, we're going to actually find the roots. So first things that we want to do, find A, B, and C. This is a quadratic equation, so we know that we have ax squared plus bx plus c, and we know that equals to 0. So we need to find A, number in front of x squared, B, the number in front of x, and C, the number by itself in this particular form. So A, number in front of x squared is 3, B, the number in front of x is 5, C, the number by itself is -2, okay? So we're going to substitute that into our quadratic formula. Let's go to another page, at least not for now. All right, so we've got our quadratic equation, but let's get rid of that. Only reason I'm doing this is because I need more space. So here, A equals 3, B equals 5, C equals -2. I'm not sure we'll have enough room. Let's go back to our page and we'll have a full sheet to write this out because this could get kind of lengthy. Discriminant, discriminant we said was 49. Nature of the roots, we said 2 real roots. Do I know what those roots are? Not off the top of my head. We can easily calculate it by using that quadratic formula. Roots. The roots are 1/3 and -2. Okay, we're gonna do the same thing for here. I'm gonna label what my A, B, and C are. Make sure that that's set equal to 0. So A equals to 3, B equals to 11, C equals to 4. I'm gonna come back. We found that our discriminant was 73, and I had 2 real roots. Let's see if we can find what those roots are. Just gonna erase this. Let's come back to my equation, and I'm just going to put the decimal notations in. So the -0.41 and also a -3.26. Do I really want to put, okay, that's the decimal of -11/6 plus square root of 73/6 or a -11/6 minus square root of 73/6. Okay, either one of those answers will work. So let's try number 3 now. Scroll up a little bit. So first thing we need to do is find A, B, and C. So in this particular case, A equals 1, B equals -2, and C equals 5. Very similar to what we did earlier, almost, except we switched the 2 and the 5 around. Okay, so let's go find our discriminant. So we'll go back to another. So I'm going to erase my ABCs and all of that good stuff. So the discriminant is -16. I know that gives me 2 imaginary, I'm going to abbreviate. That doesn't look like a G. Imaginary roots. And my roots are 1 plus 2i and 1 minus 2i. All right, last one for this page. And we have, let's go back to another equation. So the discriminant is 0. Nature of the roots is 1 real. And the roots are 4/3. I guess I could put that twice, but why not? All right, very good. Let's see. Now, as promised, here are the answers for the worksheet from lesson 4.4, quadratic formula and the discriminant. Before we jump into the worksheet, let me write a couple of things down. We have quadratic equation, ax squared plus bx plus c equals to 0. Our quadratic formula is, so I solve for x, I would find it as negative b plus or minus square root of b squared minus 4ac, all of that over 2a. Okay? Things that we need to do: know what a equals, know what b equals, know what c equals from this equation here. Okay? There's a, there's b, there's c. Okay, let's move over to the worksheet. I guess we don't need that anymore. Okay, so close this down. So in my equation, I had 3x squared plus 5x minus 2 equals to 0. Very important that my equation equals to 0. So what is a, what's b, and what's c? A equals 3, that's the number in front of x squared. B equals 5, that's the number in front of x. C equals negative 2, that's the number by itself. So first thing they ask us to do is to find the discriminant. Discriminant, if I take my quadratic formula, is just b squared minus 4ac. B squared minus 4ac. I know that b is 5, so I have 5 squared minus 4 times, I know a is 3, c is negative 2. So I'm going to multiply all this squared first. 5 squared is 25. Negative 4 times 3 times negative 2, that is going to give me a positive 24. So I find my discriminant is 49. Now, we remember that for the discriminant, if it's greater than 0, I have 2 real numbers. If it's less than 0, I have 2 imaginary numbers. And if it's equal to 0, I have 1 real number. So I know here I will have 2 real roots. Okay, so let's go back to our problem. Go back to the page here. I know that b squared minus 4ac was 49. I'm gonna leave that over here. Excuse the lines going through there. So our formula says x equals negative b plus or minus the square root of b squared minus 4ac, which I found to be 49 over 2a. All right, so a is 3, b is 5, c is negative 2. I'm just going to substitute in here. I have a negative 5 plus or minus the square root. I said b squared minus 4ac was 49 over 2 times a is 3. Okay, so what am I looking at? Looking at my perfect square paper, I know the square root of 49 is a positive -7. That actually is taken care of already because I have the plus or minus from the formula. So when I take the square root of a perfect square, I will get the positive and negative. That's already there. So we have a -5 plus or minus 7 over 6. Okay, hopefully everybody sees that. So I'm going to make two equations now. -5 plus 7 over 6, and, well, that's what x equals. And x equals -5 minus 7 over 6. -5 plus 7, that's going to give me a positive 2 over 6, which I know reduces to 1/3. And over here, x equals -5 minus 7. That is a -12 over 6. And I know that reduces to a -2. So going back to my, so what I'm gonna need more room. So we have the equation 3x squared plus 11x plus 4 equals 0. And we said that a equal to 3, b equal to 11, c equal to 4. So when I do my discriminant, b squared minus 4ac, I'm going to substitute in 11 squared minus 4 times a, which is 3, c, which is 4. So I have 121 minus 4 times 3 is 12 times 4 is 48. So I have 121 minus 48. That is actually going to give me 73. 73 is my discriminant. It is greater than 0, so I know I will have 2 real roots. Okay? So let's go back to our paper. I want to delete this. Actually, I don't need to do that. Okay, so I know my discriminant is 73. So my formula, x equals -b plus or minus square root of b squared minus 4ac, which we've already calculated, over 2a. So in that particular case, that's going to give me a -11. I'm just substituting in the a, b, and c that I found. Plus or minus, I know b squared minus 4ac is 73. Over 2 times a, or 2 times 3. So that's going to give me 2 answers. I have x equals -11 plus square root of 73. I cannot simplify that anymore, over 6. And x equals a -11 minus square root of 73, all over 6. Okay? Do I know what the square root of -6 is? I can easily put that into a calculator. And if I do that, these are technically your answers. But if I were to calculate the -11 over 6 plus square root of 73, I would actually get a -0.41. I rounded to 2 decimal places. If I put the -11 minus square root of 73 over 6, I would end up with a -3.26. Okay, so come back to page, delete all this stuff. So we've got x squared minus 2x plus 5 equals 0. Make sure that our equation's set to 0. So what did we say? A was 1, B was -2, C was 5. So we'll find the discriminant first, because that's what they asked for. Discriminant. So b squared minus 4ac. All right, so we said b is -2, -2 squared. Now watch when we squared that, it is -2 times -2, minus 4 times a, which is 1, c, which is 5. So -2 squared is a positive 4 minus 20. That leaves us with a -16. So b squared minus 4ac is actually less than 0 or negative. So we will have 2 imaginary roots. Okay, so we've got our discriminant. We're going to do all 3 of these at the same time. So x equals a -b plus or minus square root of b squared minus 4ac, which we already know, over 2a. So x equals a negative. So we know that b is -2. So I have a negative of -2. Make sure you separate that negative from the negative that b's value is. Plus or minus. I know that b squared minus 4ac is a -16. All over 2 times 1, which is just 2. So I'm going to come over here, and what did we say the square root of -16 is? So I'm going to rewrite that as the square root of 16 times square root of -1. And we take the square root of 16 to be a plus minus 4, square root of -1 to be I. Okay, so I am now looking at negative of a -2. That's a positive 2 plus or minus 4i over 2. And that's going to leave me with what? I can just write that as 1 plus or minus 2i. Okay, let's go back and write our answers in. Page, we're going to empty this out. Not empty it out, but erase it. So now we have 9x squared minus big numbers, 24x equals -16. So I can't do my quadratic formula, factor, anything until I set that equation equal to 0. So I'm going to add 16 to both sides. That gives me a new equation of 9x squared minus 24x plus 16 equals 0. So A equals 9, B equals -24, C equals a positive 16. Okay, so let's find our discriminant. B squared minus 4ac. So b is a -24. So -24 squared minus 4 times 9 times 16. All right. So now b squared minus 4ac, -24 squared is 576. If I multiply 4 times 9 times 16, oh wow. All right, where was I? Oh yes, so 4 times 9 times 16 is also 576. So that gives me a discriminant of 0. Okay, so discriminant of 0, that tells me that I have one real root. Okay, so when I put this in my quadratic formula, x equals, let's just rewrite the whole thing, negative b plus minus square root b squared minus 4ac, all that over 2a. I know that this, I know this part right here is going to be 0. So really I have negative b over 2a. So negative b is a negative 24. So negative of a negative 24 plus or minus 0 over 2 times 9. All right, so x equals 24 over 18. That is a 24 right there. And I see 6 goes into both of those, so 4 over 3. So I have one real root, which is 4/3, and it actually appears twice because it's 24 over 18 plus 0, 24 minus 0 over 18. So I get the same. It's a double root. Let's go back and put that in. Go ahead and do these. I'm going to clear this out just in case I need it. And we'll go a little quicker through these other ones now that we kind of have an idea of what it is that we're doing. We've got our formula. So really, it's all about setting our function to 0 and solving. So negative 16 x squared minus 55 x plus 10. Okay, we could go out and do our quadratic formula, but we're all about easiness here. If we set this equation equal to 0, whether you're using Desmos or whether you're using the yellow calculator, go out there and put this function in the calculator. I don't have a calculator that I can show on the screen, so just take me at the word. Go out and put negative 16x squared minus 15x plus 10. You can set that equal to y, and then go out and look for the point where this is 0. Look at where your x intercepts are, or if you're on Desmos, you can go and do the same thing. Okay, so we will find that that should be. So if you graph this and you look for your x-intercepts, you will have a graph opening downwards, and you will find that t, the amount of time, is somewhere about 0.18. We could round that up to 0.2 seconds. So spiking the ball at 55 feet per second, a distance of 10 feet, you're looking at actually less than a second, so about 0.2 seconds. All right, so it may be somewhere around the 0.18 value, but like I said, put that into the calculator, Desmos or your TI calculator, just graph it and look for your x-intercepts. Okay, hopefully that makes sense. So let's go back to last few problems. All right. So, in a volleyball game, player on one team spikes the ball over the net when the ball is 10 feet above the ground. The spike drives the ball downward with an initial velocity of 55 feet per second. Wow. How much time does the opposing team have to return the ball before it touches the court? Okay, I'm guessing that's meaning the ground. They give us our function, a negative 16x squared minus 55x plus 10. All right, so we have a parabola of some sort. And we'll just draw a little graph to kind of see what it looks like. I'm just imagining here if the ball was up in the air. I don't know if he spiked it while it was still rising up or not or what have you. Anyway, so we have some little, I guess we'll have a little parabola shaped something like that. And we'll know that this is about the 10-foot mark. Not that we need to draw that picture, but it seemed like fun. All right, scroll down a little bit. So we got a parabola like this, and this is our 10-foot. And here's the court down here. So the ball's coming at 55 feet per second. Now, it doesn't really, that 55 feet, we don't need to use that in our equation because it's given in this equation. Well, we didn't ask all that. There's that 55 velocity, whatever. Okay, so what are we doing? We know in this particular case that x equals the time. If you read that, it says somewhere in there how much time. That's what we're looking for. And f of x, our function, is the height of the ball. So we are going to set f of x equal to 0, right? Because when x is 0, we know the height of the ball is 10 feet in the air. That's when the spike starts. Okay, so we want to figure out what the other x time is when it hits 0, because these are my intercepts. This is boom and boom. Both of these cases, the height of the ball is 0. We just want to know what this time t is. T is 0 here. T is, doesn't even look like a T. This is my other time. Okay? X time, whatever. You know what I mean. Maybe you don't. So we're going to solve for x. So let's go back up our graph. All right. So we know that is somewhere around t equals 0.18 seconds. Okay. So hope that was helpful to you. All right. So a number A of laptop computers sold in millions can be modeled by this function here. A equals 4.5 t squared plus 43.5 t plus 17, where t represents the year after 2010. In what year approximately did the computer sales reach $650 million? All right, let's see. Another good question. Now, do we want to actually do the quadratic formula, or do we want to try to factor that as a trinomial? How do you want to do that? Good question. So first thing we want to do, we know A, I believe they meant the sales of computers. So we know that A equals 4.5 t squared plus 43.5 t plus 17. Okay, so we are looking for sales to be 650 million. Now, A is in terms of millions, so really we're going to place A replace A with 650. So we've reached $650 million sales using that formula 4.5 t squared plus 43.5 t plus 17. I can't factor through quadratic formula until that equation is set to 0. So I need to subtract 650 for both sides. All right, so 0 equals 4.5 t squared plus 43.5 t. And in this case, it's going to be minus 633. So again, go out to your yellow calculator, your TI calculator, or to Desmos and graph that. Okay, graph it and see where your x-intercepts are, and that should tell you the number of years. Now, once we find that number of years, which should be somewhere around t should equal about 7.97 years, which we can round to 8. Add that 8 to the 2010, and you should have a year of 2018. Okay, so graph that. Make sure that that's what you get. Okay, so let's see. What else do we have? Number 7. How do you see it? The graph of a quadratic function y equals ax squared plus bx plus c is shown. Boom, boom, boom. Determine whether each discriminant, that's b squared minus 4ac, I'll just write that over here, b squared minus 4ac, that's our discriminant, is positive, negative, or 0. Then state the numbers and type of solutions for each graph. Explain your reasoning. Okay, if you recall from the table that we looked at the other day, if the discriminant is, so I'm going to say if D is greater than 0, we know we have 2 real. If the discriminant is less than 0, we have 2 imaginary. If the discriminant equals 0, we have 1 real, and it's a double root. Okay, so look here. Where do I cross the x-axis? I don't. So that means I have no real solutions. So in A, what are we showing for this one? Let's see. It says determine whether each discriminant is positive, negative. Okay, in this particular case, our discriminant, because we don't know what it is, our discriminant, I'm just going to say discriminant has to be less than 0 or it's negative. Okay, which means we have 2 imaginary roots. And that's because I don't have any real roots because I don't cross the x-axis. Okay, I hope y'all realize that's imaginary. All right, looking over here, I crossed the x-axis on 2 occasions. So my discriminant has to be greater than 0. So I have 2 real roots. And in C, I touch the x-axis 1 time. So that means my discriminant equals 0, and I have 1 real root. Okay? Finally, what is the axis of symmetry? Circle it in the formula below. So the axis of symmetry, which is essentially the line, a vertical line that goes through our vertex. So if you recall from how do we find the vertex if we just have a standard form? We said x equals negative b over 2a. Okay, so in that particular case, for the axis of symmetry, we are going to be going through the vertex, and our discriminant should be 0. Because if it's 0, that's where the negative b over 2a comes from. So we'll just circle that because they said circle the axis of symmetry. We notice the axis of symmetry is negative b over 2a. Okay, so that's what we get. I believe that should be it for Section 4.4, quadratic formula and the discriminant. Hope that helped. Bring any questions you have to class on Thursday or Friday, whenever your test is, or during tutoring. Thanks so much.